Okay, so today we're not actually learning anything new. Okay, we're going to rehash some of the stuff that we've done over the last few days. Last year, when I taught this, the students had a really difficult time with this section, so I wanted to build in a day where we just did it again. So I am going to do a few examples today. There are no practice problems today, it's only examples. And then there is an assignment that you have to do with this. It's not long and it's not hard. Okay? So the big thing I want to do is I want to be able to look at problems and have you look at problems and decide, what rule do I use? Okay? So that's the big question here. So what rule do I use? So let's review the rules really quick. Remember, when two events are mutually exclusive, okay, the probability that A or B will occur is the probability of A plus the probability of B. The big word there is or, and the fact that they're mutually exclusive, that they can occur at the same time. If they're not mutually exclusive, we still have the word or, but we have to subtract the probability that both can happen. Now, I want you to notice here, probability of A and B, which is a multiplication rule. If you were to actually, a lot of them, you know it without multiplying them together, okay? If you didn't, you would have to do that. But I want you to know that some of this, sometimes they're easier than they appear, okay? Because you already know some of this information, all right? And what I'm trying to get at is don't do the multiplication if you don't have to, all right? If you don't have to, you already know it, just plug it in there, all right? Make it as simple as possible for yourself. Don't try to make it too hard. All right, here's the multiplication rules. Okay, there's 3 multiplication rules, and I'm actually going to, when I call these rules, okay, multiplication rule number 1, they're independent. The probability of A and B occurring, you multiply them together. Okay, when they're dependent, okay, you have the probability of A times the probability of B given A. Again, realize that the formula for the probability of B given A is given afterwards, because most of the time you know it without having to do the work. Okay, so conditional probability, we're going to call this number 3, okay, multiplication rule number 3. And we take the probability of A and B and divide it by the probability of A happening. All right, so let's look at some examples. And what I want on these examples is I want us to be able to look at the problem and say, okay, what rule am I going to use for each one of these? Okay, so we're just going to have 3 examples today. I'm not actually going to do practice problems. These are just examples. Now, if you want to know where this is in the book, this is in the review section at the end of chapter 4. So this is number 6 there, if you're looking at that. All right, so it says, during a sales at a men's store, 16 white sweaters, 3 red sweaters, 9 blue sweaters, and 7 yellow sweaters were purchased. If a customer is selected at random, find the probability that they bought a blue sweater. Now, that doesn't have a probability rule. It just is, right? So how many do we have total? We have 35 sweaters total. So the probability that it's a blue sweater is 9 out of 35. And that's it. I mean, there is no rule. That's just what it is. Okay? A yellow or a white sweater. Now, are these mutually exclusive or not? The answer is they are not mutually exclusive. So on this, we're going to write addition rule number 1. Okay? Now, the reason I'm doing this is because that's your assignment. When we're done with this, I'm going to give you certain problems, and I want you to write down what rule it is. I don't want you to do the problem. I just want you to write down what rule are you going to use to solve that problem. But we're going to continue the problem just because I want you to see these. So yellow or white sweater is addition rule number 1. So it's a yellow sweater is 7 out of 35, and a white sweater is 16 out of 35. And if I were to add those up, I would get 23 out of 35. So that's the answer to B. Okay, a red, a blue, or a yellow sweater. Again, all mutually exclusive. Okay, so a red, yellow, blue, or a yellow sweater. So this is addition rule number 1 still. Okay, so addition rule number 1. And so red, yellow, or blue. So red is 3 out of 35. Okay. Blue is 9 out of 35. And yellow is 7 out of 35. Okay. So 9 plus 7 is 16, plus 3 is 19 out of 35. So 19 out of 35 is the probability that I will select one of those 3 colors. Let's see. Okay, D, a sweater that was not white. Okay, now this is not addition rule number 1. This is just the complement rule. Okay, so I don't need to actually label that. But it's, if I have, what's the probability that it's not white? So I take the probability that it is white, and I subtract it from 1. So I do 1 minus 16 over 35, and I end up with 21 out of 35. Out of 35, sorry. And that actually reduces to, we divide those both by 7, 3 out of 5. Okay, so that's a probability that I will get a sweater that is not wet. Okay. So you have to be able to read a question and decide what rules you're going to use. I think that's one of the hardest things is if you're given a rule specifically and say use this rule for this problem, you can do it. But if you're not given a rule, sometimes it's a little harder. Okay, so let's look at the next example. Okay, so this is probability of events that are not mutually exclusive. All right, so there's a 39% probability that John will purchase a new car, and a 73% probability that Mary will purchase a new car, and a 36% probability that neither will purchase a new car. Okay, so this is another one that this is like the example I did before, right? That it's neither. So we have to find out what the probability that them both occurring is, or the probability of it occurring, and then subtracting it from 1. So first of all, so we're going to go 1 minus the probability of A or B. So this is addition rule number 2, okay, with the complements in there, but it's addition rule number 2 that we're using. So we're going to go 1 minus, big parentheses, the probability of John buying a new car plus the probability that Mary buys a new car. Minus the probability that they both buy a new car. Right? And calculators are easy on that, and I end up with 0.24. So there's a 24% probability that neither one will buy a new car. All right, multiplication rules and addition rules. This is combining. These are all fun and exciting. Okay. So wash my place in my notes. Okay. So multiplication rule and addition rule. We're going to use both of them. So let's look at the problem first, because I put them on here so we know. But it says a manufacturer makes 3 models of a television set. Models A, B, and C. A sells 40%. A store sells 40% of model A, 40% of model B, and 40% of model C. Okay? Of model set A, 3% have stereo sound. Of model set B, 7% have stereo sound. And of model set C, 9% have stereo sound. If a set is sold at random, find the probability that it has stereo sound. Okay, so it's a lot that we have to read into this problem. So first of all, we're looking at what's the probability that it has stereo sound. Okay, so we have those probabilities. Okay, but we also have, so it's of the model set A. So this right here is of the model set A. It's basically saying, okay, we have model set A, and we know that probability, and we need to multiply that probability times the stereo sound because it's that it is A and it has stereo sound. So I know it doesn't say the word and in there, but you have to think of it that way. All right. Model set B. Okay, so B, you're selling B and you have stereo sound. You have selling C and you have stereo sound. So what is the probability that it has stereo sound? So we're going to say 40% A times 3%. Okay, the probability that the first set will have stereo sound. Then we have 40%. The B sets times the probability that this one will have stereo sound. And we have 20% of C sets times the probability that one has stereo sound. So if we just were to select one at random, what's the probability that it has stereo sound? Okay, well now we've given the probability of each one, we need to add them together. So that now we know what's the probability that we have total number has stereo sound. This is a tough problem. This is a hard one to move through sometimes. So I probably will have to go over this one again, I bet, in class. So if I were to, I'm using multiplication rule number 1 because they're independent. I'm also using addition rule number 1 because they're mutually exclusive. Set A is not set B. All right. So if I were to add all those up, I would get 0.058, which means I have a 5.8% probability that if I were to select a television at random, it would have stereo sound. So, all right, example 4, okay, and this is the last example. So the probability that a customer will buy a television set and buy an extended warranty is 0.03. If the probability that the customer will purchase the television set is 11%, find the probability that the customer will also purchase the extended warranty. Okay, so again, lots of words that are not set here that we need to pay attention to. So we know that the probability a customer will buy a television set and buy an extended warranty is 3%. So any customer walking into the store, we have a 3% chance that they will both buy a television set and extended warranty. That's my probability of A and B. Okay, that's already given to me. And I want to know if the probability of that a customer will purchase a television set is 11%. Okay, 0.11. That is the probability that they will walk in the store and they will buy it. That's probability A. Okay, find the probability that they will also purchase the extended warranty. So it's the probability of both of them occurring divided by the probability that A occurs. This is the probability of A and B, the probability of B given that A has already occurred. All right. So this is multiplication rule number 3. So if I divide those out, I end up with 0.27. So if we already know that a person has purchased a television, the probability that they will purchase an extended warranty is 27%. Okay, so that was the 4 problems. It took almost how long to do those as it did in the normal video. I did a lot of talking. So what I would like you to do, all right? I want you to look in your book, and you have the books online, okay? The end of chapter 4, on page 229. And I want you to look at these particular problems, 9, 11, 13, 15, 13, 14, 15, 17, and 19. And all I want you to do is read the problem and identify the rule. If you don't have time to do all of them, at least do 2 or 3 of them, okay? Just so that we have something to talk about tomorrow. Tomorrow we're actually going to do these problems in class and not just the practice part, but just make sure that, that you're able to walk through the problems and check them out. And that's it. We'll do the problems tomorrow. I'll see you tomorrow.